Hi, we're doing Fall 2010 Exam 3, Blue version. So for number 1, problems A through C, consider the pairs of molecules drawn below for each case, A through E, and circle the number that corresponds to the entry that best satisfies the statement. So these are our 1s and 2s type problems, and the first one is asking for which one is the better SN1 solvent. Well, we know that just from our notes that the better SN2 solvents are protic solvents. Oops. Whereas for SN2 we want aprotic solvents. So just from knowing that, something that's protic is something with hydrogens. Water has hydrogens, so that's something that's protic. DMSO actually is one of those aprotic solvents, dimethyl sulfoxide. It was actually a starred molecule, and it's known as one of the major aprotic solvents. So just from knowing that, we know that the answer is water. And remember, with SN1, the reaction is a solvolysis reaction where you have a weak nucleophile, such as water, and so you want more of that weak nucleophile as your solvent. Therefore, that's why we want the protic solvents. So that was the answer for part A. Part B, which one is the weaker base between LDA and this molecule right here? This is like an acetylide ion, sodium acetylide. So here I just drew out the structure for LDA. Just from our notes, we know that LDA is like a flame-throwing base, one of Dr. J's flame-throwing bases. So from there we know that that one is very, very strong. So just from, knowing that, you could have chosen this one, but you can actually see through the protocol why LDA is going to be the stronger base. So when you're looking at the structure of LDA, it has 2 isopropyl groups, and remember the whole debate about inductively donating groups. So carbon chains are inductively donating groups that they localize charge density to the atom with the negative charge. So it has 2 inductively donating groups on either side of it, making that charge very unstable. Whereas with the acetylide ion, remember triple bonds have really high percent S character, making the negative charge more stabilized because the electrons are closer to the nucleus. So therefore, that's why that's going to be our weaker base, and the conjugate is the stronger acid. So that's the spiel for that one. Part C, acetylene versus ethanol. Which one is less acidic? So, okay. So what I like to do when I see acidic is I like to just follow the protocol. When you see acid, you want to treat these 2 things as an acid. So that's what I did. I treated them as an acid and I deprotonated them. And then I consider their conjugate bases. So it's asking for which one is less acidic. Therefore, we want to look at the conjugate bases. So here we have a negative charge on oxygen, and here we have a negative on carbon. Which one is better? Negative on oxygen is better. Remember, electronegativity of size doesn't really come into play for these 2 because they're on the same period, period of the periodic table. But electronegativity does come into play. Oxygen is more electronegative than carbon, so it stabilizes that charge better. So if this is going to be the stronger acid, then this is going to be our weaker one. So this one's going to be less acidic. And that's because its conjugate base, well, the conjugate base for our less acidic molecule is more unstable than the conjugate for this one. So.